Hello, welcome back, space fans. Welcome back to Space to Alive after a short break. Um, Welcome to Nick and Terry, our space experts
Hi.
and astronomers on the Space Roundup. I hope everyone has been well over the short break. We're back tonight with another cracking episode of the Roundup. This is where we bring you the latest and greatest of space news. And there's a lot that's happened while we were away. But firstly, a warm welcome to Nick and Terry. How are you guys doing?
Very
Great.
good.
Good to be
Lovely
back.
to be back. And
Yep.
a huge thank you to Space Store for keeping the faith and rocking on with something now that this horrible pandemic's almost coming to its logical conclusion. So we all hope, hopefully driving this forward and continuing to give everyone who listens and tunes in some fun facts about space.
Yep. It's given people that wouldn't normally have had a chance because they couldn't go to live meetings. They're getting a chance now to participate in events like this. So it did have some benefits.
Yeah. It's one of the best. I think this, I know you guys at Space Store are really in tune with companies like Astro Agency and what they're doing with the space bar and stuff. There's been some great Zoom events, and we're just really proud to be knocking out some cracking STEM, we hope, and entertaining people at the same time.
Yep.
Great. Well, I hope you have a great show tonight. And just to note that on this Thursday, we'll be back with the Space or Live Thursday night talks. And we're going to be speaking to someone from Astro Agency. So tune in Thursday at 7 p.m. But before, I'll let you crack on with tonight's show.
Excellent.
Okay.
Great to be back. Let's just rock in because we know that there's some football match or something starting in about 30 minutes or so. So we want to barrel through this, but feel free to watch this again on YouTube. This mega comet, this was massive news, and we thought we've just got to cover this because a lot of the popular press, the Independent newspaper being one example, which was quite shocking actually, was saying, oh, there's this gigantic comet and it's coming straight towards us. It's not. Anyone who's watching this, and if you watch again on YouTube, do not panic. We're not talking about Armageddon here. We're not talking about even deep impact. We're talking about, yes, this is a big comet. So Bernardinelli-Bernstein, why are comets always so hard to pronounce? Cheremeyev, Gerasimenko, another one, 67P. This one, C2014 UN271, great comet, discovered in 2014, or from data from 2014 from the 4-meter dark energy telescope. So this thing's been known about for quite some time, but now that they've got this really, really precise orbit on it and really good data on what its visual magnitude is, and it's still up for debate, this, because it could be anywhere between 50 kilometers wide to 300 kilometers wide. There's all sorts of different scope for this, depending on like which data you're looking at, etc. There's been images taken of this from the Falks telescopes down in South Africa, from various scopes all around the world that are really monitoring this. Now, if it is 100 kilometers wide, we've got potentially one of the most spectacular comets in living memory in terms of physical size. Unfortunately, the closest it's going to get to the Earth is about 10.9 AU, which is around about the distance from the Earth to Saturn. So it isn't really going to even light up, because the thing about comets, and I've given loads of talks on this, but comets are really interesting. So comets are typically found in two main regions in our solar system, in and around our solar system. One is known as the Edge-Earth Kuiper Belt. This is where New Horizons is currently exploring, where Pluto is, these kind of trans-Neptunian objects between the orbits of Neptune and Pluto and beyond. And this is literally swarming with comets, typically what we call short period comets. So comets with a period under, say, 200 years or so, comets like Comet Halley, which has a 76-year period. These are the ones that you would typically, not always, but typically find from this region. So they kind of barrel around, and there's estimates anywhere between 200 to 800 million of these in the Kuiper Belt. We still don't know. We're still detecting new ones all the time. Say we astronomers with big telescopes. So these things are swarming around in this kind of nice orbit, and occasionally something will happen. There'll be a gravity perturbation, something will bump one into another, and they'll slowly drift in towards the sun. Sun being the biggest gravitational force, obviously, in our solar system, because it's the largest object. So they'll just kind of drift in. Occasionally they'll get caught up in the orbits around other planets, Jupiter being a great example with Shoemaker-Levy 9 back in the early 90s, which when that comet first encountered Jupiter, Jupiter literally shredded it into 21 separate pieces, and then it collided with Jupiter, and wham bam, thank you ma'am, massive impact scars. If you look at the impact scar sizes, they're literally, some of them almost the size of the Earth. So had that hit us, we wouldn't be here. There'd be nothing left. The thing that wiped out the dinosaurs, comet or asteroid, still up for debate. There's a lot of leaning towards a cometary object now, but that was estimated to be about 15 kilometers wide. So about the size of Manhattan Island, perhaps, where New York is. And you think, well, that managed to wipe out 76% of all life on this planet. All the dinosaurs that have been happily munching away for 200, 300 million years, wiped out, gone. So we don't want a large object to hit us. Now, this thing isn't going to hit us, but it is massive. I mean, Hale-Bopp in the late 90s, that was estimated to be about 35 kilometers wide. This thing, as I said, estimated at around about potentially between 100 to 300 kilometers wide. So if this thing were to strike the Earth, that would be it, game over. There'd be nothing left on this planet alive at all, bar cockroaches and Keith Richards. That's literally all that would live. The thing is, it was detected way out at about 29 AU. This thing's got an incredibly long orbit as well. It's a 4.5 million year orbit. So, and typically, Kuiper Belt, this isn't from the Kuiper Belt. This is, so I was going on to where comets come from. So I talked about the edge of Kuiper Belt. This is from the other region. This is the Oort cloud. So the Oort cloud is, again, this massive cloud of comets, which they think is around about anywhere between 0.6 and 1.4 light years away from the Earth. Now, if you think about that as in terms of a distance, the Voyager spacecraft are currently around about 17 to 18 light hours away from Earth. They're some of the fastest spacecraft ever built. And they've been flying out of the solar system since 1977. So it's a long distance. These things take potentially millions of years to come in to our neck of the woods. Now, typically, when I say it's not going to light up, typically what happens with a comet, as it approaches the sun, the energy from the sun starts to sublimate all of the gas, all of the ice, etc. on the surface. That turns into these gaseous halos, and you get the comet streaming away, the ion tail and the dust tail, streaming away from the sun. As it gets closer and closer, this tail can get bigger and bigger, and the halo around the comet can get bigger and bigger. And sometimes it can be absolutely enormous. Comet Holmes being one example where the coma around it was absolutely gigantic. The tails can be several 100 million kilometers long, but it's very tenuous, very fine particles. Sometimes the Earth does intersect these. There was a famous example with Halley's Comet in the early 1900s, where everybody went out selling comet pills and comet gas masks and all sorts. But we do crash through all of these dust tails pretty regularly. The Perseids being a classic example of this, where the Earth intersects the kind of remnant tail of a comet. The thing about this, and the interesting angle I'm thinking on this, I don't know what you think as well, Terry, was although this isn't going to come to its closest approach until 2031, as I said, that's at 10.95 AU. So around about, as I said, the distance of Saturn. It would be fantastic if, given the progress we've got now with space missions, etc., that we could launch something, possibly on Falcon Heavy, or if Starship's ready on time, launch something that could intercept this, that could basically go and even do a flyby just to see what a comet of this scale was really like. I think it'd be fantastic. The third region where comets come from, we've only recently discovered. I mean, there's some comets in the asteroid belt, kind of anomalous asteroids, which are in fact comets, but with some of the objects we've detected in the last few years, these are kind of intergalactic comets. These have come from other solar systems. Mama being, pardon my expression in terms of phrasing, being the best example of that, where everybody thought it was an alien spacecraft. It isn't. It was just a very weird, elongated cometary object. My big take on this, and as I said, it'd be interesting to see what Terry thinks, is if this was on a collision course to Earth, this would be the best wake-up call ever in terms of what's going on right now with space. We've got something 100 kilometers wide, and we've got a 10-year heads up. We know it's coming into the inner solar system. In 10 years, could humanity develop something that was large enough that could deflect this? And I don't think we could. But it should be, in my mind, a real wake-up call to the entire world, or every politician, etc., to say, if we continue to litter low Earth orbit with mega constellations that are already decimating radio astronomy, there was a story that came out today about the impact on the Square Kilometre Array and literally decimating radio astronomy and optical astronomy. If we keep doing that, we're not only going to find it more and more difficult to find these things, because the optical astronomy surveys that look out for these objects are being hampered by these swarms of satellites that's only growing exponentially all the time. But if we've got so many in low Earth orbit, and then we have what's called the Kessler syndrome happen, which is where you get this catastrophic domino type effect, where certain orbits will literally be impossible to launch into and put objects through. And it could be incredibly difficult to launch through these if there's so much debris up there. then we've got no way of stopping it. I don't know, Terry, your thoughts?
I was thinking exactly the same thing as you in terms of sending out a mission, but I'm not sure that it's really practical. Normally for something like that, you're talking about a 4 or 5, maybe 6 year development period, which would take you up to, 2026 roughly. Then you have to get it out there.
Yeah.
And okay, we're getting bigger and heavier and faster rockets all the time. It's certainly worth thinking about. Now, you might need, in fact, you almost certainly would need a gravitational assist to get it out to the orbit of Saturn in time. I was just thinking in my head that Jupiter and Saturn at the moment are approximately in roughly the same line of sight. But by the time something would actually be launched and get out as far as Jupiter, they will have separated quite a bit. Now, I'm no expert in orbital dynamics, but at a first glance at that, I don't think the geometry would be just right. But certainly with something we're going to be talking about coming up shortly, the big rocket just being developed, it might be possible to get it out there without a gravity assist. As you know, that's what was used for the Pioneers and the Voyagers and so on. But yeah, we're not going to probably get another chance to look at something as big as this from the Earth cloud for quite a while. The thing about that is the Earth cloud was just purely hypothetical. People thought there must be a reservoir of comets away out there. Otherwise, where are they coming from? And now we're getting observations of actual objects that we can say from their orbits have actually come from there. And as you say, this is a big brute of a one. If something like that was heading for us, we would want to know as much about it as possible in terms of its density, its structure, and so on, to know how to deal with it, if we could deal with it at all. So if any people are thinking in terms of getting a space probe out to it, and it's doable, it's very well worth doing.
I was just thinking along the lines of, as the European Space Agency did with the Venus Express and Mars Express, where they effectively utilized the same spacecraft hardware technologies in 2 separate missions. And I was just thinking, if you had even an engineering spare, as it were, or a flight-ready spare of something like New Horizons that you could put on top of a rocket with sufficient delta V to give you that incredibly fast burn, getting it out into a deep space orbit. And I said it probably would require some kind of gravitational assist. I'm not sure what the alignments are like right now in terms of doing that, but I think it'd be fascinating. The other interesting thing with this is this may be just the first of many. Yeah. If something is out there that is causing a gravitational perturbation in the Oort cloud that we don't know of yet, that we're not aware of, it could be, as the listeners may or may not know, our solar system is going around the center of our galaxy once every approximately 250 million years. And as it's doing so, it's dipping up and down through the galactic plane, and it is encountering other stars and objects in space, which will cause gravitational anomalies, as it were, that can result in throwing in objects like this. And as I said, they can take millions of years potentially to get shifted from the Oort cloud, where their velocities could be extremely slow, into incoming towards the sun, where some comets, when they reach their closest approach to the sun, are traveling anywhere up to 187,000 miles an hour. Now, if you've got an object traveling that fast, that's that big, there is nothing stopping it. Absolutely nothing. You can throw every nuclear missile you wanted. You could throw whatever you want at this thing. Nothing would stop it. You watch Armageddon, you watch Deep Impact, and they're great films and they're a lot of fun, but rubbish. Absolute guff. So I'm seeing in the chat people are saying they're concerned. Yeah. Don't be. This one isn't coming our way, but we do need to be aware of this.
Yeah, it won't come within the orbit of Saturn. Basically, we know that for a fact, and that's roughly 10.9 light minutes away, or sorry, AU, astronomical units away. Now, there's one other angle. I was just thinking again, we're thinking live on this. We wouldn't have to intercept it exactly at January 2031, which is the actual moment of perihelion. It's still going to be relatively close to us for a year or two after that. Yep. But the thing about the orbit is it's very highly inclined, 95 degrees. So it'll be in the plane of the solar system round about that time. But a year or two later, when it would still be interesting enough to explore it, it would be fairly well out of the plane of the solar system. So it just wouldn't be quite so easy to get a rocket to it.
No, at that point, you'd literally have to fly over, say, the top of Jupiter or the underside of Jupiter, to get, absolutely. Sorry, Terry, carry on.
that's more or less what I was going to say. Some other interesting things about it. It's very red, apparently, which usually indicates that there's a rich coating of organic material on it. But I don't think anybody has ever thought about how that actually might develop as far out as the Earth cloud. And it's very low albedo. They estimate between 1% and 8%. So even though it's pretty big, it's just not going to get all that bright unless it outgasses significantly, with a huge coma. But we have very little experience of something as big as this at that distance. Comet Sarabat is another one that was supposed to be roughly that size back a couple of centuries ago, but basically we just don't have enough information about it to be sure. So this one is like a Oumuamua. It's a chance in a lifetime to try and get something, some information on something like this. I mean, there could be another one of these next year, or it could be another century before there's another one. So we should really make the best of our attempts on this one.
Yeah, as I said, let's hope it's not the start of something. If we start to see a lot of these, then the people who are saying, I'm concerned in the chat, then you start getting worried because,
still the odds are
incredibly small. But then you look at Hale-Bopp, Terry, if you remember Hale-Bopp's orbit, and they calculated that had it been a month, I think it was either a month later or a month earlier, it potentially could have been on a collision course with the Earth. And that was like several 100,000-year orbit. So never say never, as they say. Things can happen. The dinosaurs probably thought, oh, we're okay 66 million years ago. And then wham, bam, thank you, man, they're gone. Anyway, moving on. That's a cracker. And Bernardinelli-Bernstein, it's kind of, I was tempted to say Watergate, if you remember Woodward and Bernstein, but the Watergate comet. But no, let's move on to our next interesting story, I think, about what's happening with the Chinese. So
I mean, they never cease to amaze. Basically, I think percentage-wise, they must have a higher percentage success rate on their missions, whether it's to the moon or to Mars or their now manned space program. They have had failures along the way, but basically, to get a rover down on the surface of Mars and quite an advanced bit of kit on their first attempt is very, very amazing. Good going. So it's the Tianwen-1 orbiter, which is that's also the name for the whole spacecraft. But it then detached the rover, which did 11 minutes of terror and 9 minutes of terror, depending how you define it, descent down to the surface, and has then deployed the Zhurong rover, which is roaming around on the surface of the planet at the moment. And again, to get everything right with that mission first time is very, very good going. The big rocket that the Chinese have, not quite as big as the other ones that we're going to be talking about shortly, the Long March 5, but it's a very powerful beast. Did the work, got it out there. It's landed in Utopia Planitia, which is a very flat area of Mars. And in fact, if you look at any of the video or photographs that have come back, it's incredibly flat. And actually, there are very few sizable rocks on it compared with where Perseverance is exploring. There's a fantastic panoramic video of that that you can see online. So, I mean, this is just a totally amazing achievement to get it right first time. They had a few differences with their landing technique compared with Perseverance, a much longer, shallower entry angle. And instead of having the sky crane to lower the thing down onto the surface, it actually went down with its own simple reverse thrust landers until it was right down just a few feet above the surface, and then they switch off and it touches down. So that shows just how successful they can be. The other interesting thing is that they have now announced that they plan to get humans on Mars by 2033. Now, people that have heard us talking before will have heard me say on a number of occasions that I would not be at all surprised if the first human feet on Mars were Chinese feet. The other interesting thing, again, comparing with what we've been just talking about, the Chinese space program seems to be very pragmatic. They're interested in, obviously, the space station, their own space station in Earth orbit. They obviously have all sorts of surveillance satellites, both military and meteorological and geographical and climatological, etc. They're also interested in the moon, both on the near side and the far side, and they're interested in Mars. But they're not doing any of these pure science missions to the outer solar system, like, for example, the Voyagers and so on, and the missions to Jupiter and Saturn that are, like Cassini and so on. They seem to have a purely pragmatic interest. And maybe that's, you can't criticize them for that. They're doing so well. But they seem to be interested in what practical use there might be in exploring the moon and Mars, rather than just purely the science. I don't know what you think about that.
Completely agree. I mean, you look at their kind of intent, as you said, 2033 for a crewed mission to Mars, and you wouldn't bet against them. Their whole progress, and we've been talking about this for years, Terry, almost following the Mercury, Gemini, Apollo trajectory, where they, small steps, test it out, make sure it works, get it right, keep going. And as you said, European Space Agency and the Soviet Union, as was, and the Russians as now is, haven't managed to get anything onto the surface of Mars that's worked in 50 years of trying, apart from Mars 3 for 12 seconds, and Beagle 2 obviously made it to the surface, but obviously didn't deploy. But to do this first go, as you said, is quite remarkable. They're also talking about, you talked about Long March, and my issue, I work for a defense company, my issue with obviously the Chinese space program is a lot of it's very covert, and it's a real shame because they do some fantastic scientific work. But then obviously with Long March, there was a whole issue of it coming back and uncontrolled re-entry of a massive booster stage that literally could have hit anywhere. Luckily, it landed in the Indian Ocean. It didn't harm anyone, didn't kill anyone. But this kind of we don't care attitude was slightly disconcerting. China also have their own plans for a mega constellation of satellites, communication satellites, because why wouldn't they? Why are they going to trust a United States, Starlink, or a European with OneWeb in the United States constellation? They're not. So they're planning on putting up 13,000 of their own satellites. Then we've got the Russians are going to probably be doing the same kind of thing. I do agree that it's an interesting approach that they're focusing on the moon. Obviously, you've got the potential for lunar exploration via mining. You've got resources. There's all sorts of things. And it's also national pride. China, if China beat the United States to Mars, it will be the equivalent of the Apollo program. Let's be honest here. Since 1969, humanity hasn't done anything spectacular in terms of human spaceflight. We've gone around the Earth, we built Skylab, we built the ISS, fantastic as they are. They're no more than 400 to 500 miles away from the surface of the Earth at any time. The furthest we've been away, I think, is to service the Hubble, and that's at 450 miles away from the Earth since 1972. So the space race, which was geopolitical in its intent, and obviously we got some fantastic science back from the Apollo and the lunar program, but essentially it was all geopolitical. And for China now, who want to be the dominant global world superpower, as it were, to be really setting their sights on some fantastic scientific achievements. I mean, landing on the far side of the moon, being able to do the data relays before pretty much anyone else is doing it in the way that they're doing it. Now with the first attempt on Mars, not only getting a lander on the surface, getting a rover and a lander on the surface, doing real science it is astonishing. So I think it's going to be a real, almost like a 3-horse race now between the Bezoses and the commercial aspects, elements of this world, via the United States or whoever, and China. That's what it's going to be against. Now, if China were to partner up with, say, India and Russia, they could have a truly terrifying, and I don't mean that in a bad way, but a truly terrifying capability, because Russia, don't forget, have got some of the most successful launch vehicles in the world. They've been doing Soyuz launches pretty flawlessly now since 1961, 1957 even, but 1961 with humans. So I think it's worth keeping an eye on. As I said, it's a real shame that we don't get to hear very much about it. We'll get the occasional video, and those videos are stunning. The video of the rover on the surface where it dropped the camera and then took a high definition selfie video was, again, quite remarkable. And that, if China were as good at PR as the Americans are, they'd be making global news constantly. But it's almost like an afterthought on the BBC and I'm guessing sort of the US channels as to, even showing it at all, which is as I said, is a real shame because they do some great science. But anyway, so it kind of ties into the next part of the story, which are these remarkable rovers. And, it's the first kind of toe in the water, I think, for the surface of Mars for them. But they've got intent to to do this again and to bring back soil samples by 2030. Now, if they achieve this, they will potentially beat the joint NASA European Space Agency mission, which is aiming to bring back sample returns. Now, obviously, they've got the rover on the surface already. They're dropping they've been able to collect the rock samples, soil samples, put them in the canisters ready for the next retrieval. But that's reliant on the next retrieval mission, which is the European ExoMars, being successful. And as I said, in 50 years of trying, and this is being launched by a Russian Proton rocket, and it's an Airbus predominantly developed mission. We wish them all the best luck in the world. But if you want to talk about hoaxes and jinxes, 50 years of trying, they've not done this yet. So, and if that fails, that whole timeline for the European sample return mission goes out the window. Now, if China have got a successful method, and essentially what they're doing is what Viking did, they're using retro rockets. They're doing a slow descent retro rockets, and they're probably not as concerned about the contamination. The issue with the Sky Crane was obviously they didn't want to get dust into the delicate instruments on board what is a vastly more kind of developed rover. I mean, the Zhurong rover is kind of like Spirit and Opportunity. It's their version of something that America landed over a decade ago and was successful for years and years, way beyond its lifespan. Hopefully Zhurong will be the same, and we'll get loads and loads of science back from that, again from a different region on Mars. But we'll see now what's going to happen in terms of this race, not only to get humans on the surface of Mars, but to get a sample return back. Because if China beat America and the European Space Agency to that as well, then again, it's another notch in their, national pride bedpost, as it were. So don't be fooled by the science aspects. It is geopolitical. China have got a very good agenda here, and it's only got to be applauded, I think. I don't know.
Just before we go on, Nick, I see there are a couple of comments there. One from an old mate of mine, Mike Phelan, talking about India. They also have a very ambitious space program.
Absolutely.
They're not as far on as China, but they also will be developing another independent space program, and there's nothing to say that in maybe a couple of decades they won't be a major player. Also, one or two other comments that are interesting, going back to the Comet DB, just to give it a short name. We'll have some really big telescopes available then, the ELT, the Giant Magellan Telescope, hopefully the James Webb. Now, it's sort of well into the infrared end, and this object isn't quite in the infrared, the Comet, but it's certainly on the red end of the spectrum. Might be possible to get some excellent images of it from that, those much bigger instruments that we have now. Still not a substitute for a close flyby, but there are certainly prospects of getting good images from it.
Absolutely. And don't forget the James Webb, again, fingers crossed that works and that launches successfully via the Ariane launch that they're planning. Hopefully later this year, early next year. It's continually being delayed, but let's see. The spectroscopy capabilities, you're saying about the organics on the surface. If they were to detect really complex organics on the surface of this thing via detailed spectroscopy from instruments on board the likes of the James Webb, and something we're going to be talking about in a little while as well, if they can get that working again. We could be getting some spectacular images, but you only have to look at the kind of images of 67p that were taken from the ground-based instruments, and also even from the spacecraft from Rosetta as it was approaching. And they said, it looks a little bit like a duck, a kind of kid's toy duck in a bathtub. And then when you get up close, the complexity and the beauty of the structure of that is unbelievable. Yeah. So a flyby, and you look at so many of these small missions, you talk about India and the phenomenal success they had in getting an orbiter to Mars, literally first go again, pretty much, and for the cost of a Premiership football player. It was remarkable. And then the UAE, we're not hearing very much from the UAE, but again, these small kind of agile, there's a terminology that we use in software development, agile methodology, which is kind of build, make mistakes, build again, make mistakes. This is how SpaceX is succeeding. They've got the money to do it. They keep going, right, okay, we've blown a rocket up. What do we do now? Let's build another one. Let's build another one. And then eventually they get it right. And that methodology is how we should be doing spaceflight now. You've got to take the costs into consideration, of course, and you've got to take the potential for human life loss into consideration. Because at the moment, if you're testing just robotic rovers, if one of them blows up, it's a robot. And yes, the principal investigators and the scientists are going to be decimated and upset, but nobody's died. When that happens, and let's not beat about the bush here, it's going to happen. it is going to happen. Somebody's going to, we've obviously had the Challenger disaster. We had Columbia. We've had obviously the Russian space station in the early 70s where 3 cosmonauts on board died. People have already died in space, but this is going to become commonplace, like air crashes, like boats sinking, like cars crashing. It's going to happen. We hope it doesn't happen very often, and we hope when it does happen, we learn lessons and we move on really quickly. And that's the best way with anything in life. Just learn your lesson and move on really quickly. So that's kind of my thoughts on this, Terry, which brings us neatly on to our next topic, and big telescopes and imaging that comet. And the biggest and best of them, as it is in terms of what we have in orbit, the most successful scientific instrument in human history, the Hubble. Now, the Hubble's in deep trouble. And this one may not be fixable. So in the past, we've had the various service missions. We've had, Iron Mike and Drew Fusel and various, Kathy Sullivan, all sorts of different people go up and put their hands on the Hubble and touch it. The Hubble huggers, as they're known, and they're a wonderful group of astronauts. Obviously, the Hubble was designed and built. It's in low Earth orbit. It was serviceable when the shuttle capability was about. Now, it's not to say it couldn't be serviced again. You've got companies like Sierra Nevada. Obviously, you've got SpaceX. You've got a whole range of different companies who are planning, various missions that could essentially do what the shuttle was able to do in the past, especially Sierra Nevada with their kind of mini shuttle. If you had the capability to approach something like the Hubble and grab it using a form of robotic arm and service it again, don't count it out. It's got their grapple hook that they fitted on during the last surface mission where you could boost it into a slightly higher orbit to give it a longer lifespan, as it were. But as of mid-June, one of the primary computers shut down. And it was a failure in one of the memory modules on it. And don't forget, the computers and the memory modules on this, some of this stuff is dating back to the late 70s, early 80s in terms of research and development and design. And whilst, as I said, it has been the most successful scientific instrument in history, it's had multiple servicing missions to replace the cameras, fix the optics. Obviously, we had the first thing with Perkins-Elmer with the mirror, which was out by fractions of a millimeter, putting it bluntly, but still made it out of focus. We can't do that right now. And we've got reaction wheels, which are the things that kind of orient it in space. We've got gyroscopes, etc. All of these things are critical. And it's been exposed to thermal cycling. This thing's going around Earth orbit. It's going into darkness, into light. So it's going from, minus a couple of hundred degrees or minus 100 plus degrees to plus 100 plus degrees regularly. That level of thermal cycling plus the radiation it's been exposed to, and with radiation, the microprocessors on board the computers on these spacecraft have to be radiation hardened. So you get what's called C events, single kind of excitation events, which basically will cause the microprocessors to do anomalous things or break in potentially some cases in what they call TID events as well. So there's lots of different kind of radiation events that could harm the computers, and clearly something's happened over the past few months that's caused this computer to shut down. When they went to the backup system, again, that wasn't working. So right now, NASA are taking this very careful, slowly approach. They've still got uplink and downlink. They can still control it. They can still move it to effectively take observations. And why would they do that if they're not capturing any data? Because the computers have failed. Well, they're doing that for the thermal cycling. They need to make sure that the telescope's thermal management is maintained. They also need to maintain the power to the telescope. So the solar panels have to be oriented in certain ways. And the way that they do that is by moving the telescope to do these observations. These are all very carefully planned. So they're continuing to do that, but not able to capture data. If they can't fix it, the question then begs, what do we do? Because to my mind, and hopefully I know you'll agree, Terry, if this gets dumped in the Pacific, it's going to be the biggest crying disaster in scientific history. This thing should not be just dumped in the Pacific, putting a grappling hook on it so they could deorbit it and chuck it in the Pacific. If you're going to bring it down, do the Elon Musk, he was laughingly saying he could do the angry alligator from the James Bond movie in the late 60s and capture stuff in orbit to try and remove debris. Who knows if he was joking or not? Probably was. But if we could capture this thing, even, major segments of it, and bring it back and put it in the Smithsonian, you'd have queues going, not around the block, you'd have queues going outside of Washington to see this thing, because it is so iconic. And we don't want this to happen. Computer troubles, we've talked about cybersecurity in the past, and this hacking that is now hitting everybody. It's hitting everybody's home computers. People are getting text messages, scams, all sorts. This happens to space as well. You can hack into ground uplink, downlink facilities. You can hack into satellites. So we don't want that to happen. Obviously, this isn't the case here. The computer's just failed, but I don't know what your thoughts are, Terry. I just want to see it saved.
Yeah, me too. I mean, it's been the most phenomenally successful instrument. It's already well past its design lifetime. It has so far performed or taken 1.5 million science observations since it went up. This unit that has just failed actually is one of the ones that was replaced. I think it's called the Science Instrument Command and Data Handling Unit. And that was replaced in the last servicing mission in 2008. That's 13 years ago. So this thing has been going since then. And it has performed 600,000 observations since that particular period, bringing the total up to 1.5 million. Absolutely iconic, as you say. Now, it's not going to be easy to bring it down, and we couldn't do it this year or next year. But if it cannot be saved to get it working again, it is possible to move it to a much higher orbit and keep it there in relative safety until we could develop some sort of a technology. Basically, you need something the size of the shuttle bay to bring it down intact. And that's not going to be easy. And I know there are shuttles lying around, but I don't think anybody's actually going to contemplate launching one of them again. But to bring it down intact, you do need something with a pretty big cargo bay to bring it down. It's doable. It's not doable maybe in the next 5 years or maybe not even the next 10 years, but it's certainly doable within a couple of decades. So all you need to do, if it can't be fixed, is simply move it up to a higher safe parking orbit and leave it there. It won't come to any more harm than it does happen at the moment, and then see if it's possible to bring it down. And as you say, it would be well worth doing. Absolutely.
It brings us neatly on to our next topic, actually, when you're talking about large cargo bays and the capability. We've been following this, obviously, through Space Store since we started these broadcasts. They're now getting pretty serious. So after 5 attempts, they finally got their Starship to land, and that was a truly wonderful moment to see. My love-hate relationship, which I've well documented with Elon and his Starlinks, is well known. I'm quite happy to say that they're an abomination, and I absolutely hate them. But what he's doing with Starship is quite remarkable. And watching that thing take off and then land successfully, given the size of it, and we're talking about something that's 150 feet high here, doing a vertical takeoff and landing when most space agencies around the world can barely get their things to launch, let alone land again, is incredible. He's going for an even more ambitious test now. I mean, the speed of development with what Elon Musk is doing is astonishing. Now, what they've got here is the Super Heavy. What you can see here is what's called the Super Heavy. This is the booster stage. So this is the kind of the main grunt thrust work, as it were, behind Starship. This is what's going to take potentially humans to Mars if Musk has his way. Definitely to the moon, without any doubt at all. Although it's going to be quite interesting to see something the size of Starship land on the lunar surface, given the horrendous nature of lunar regolith. And you only have to ask any of the Apollo astronauts just how bad it was. They'll tell you they were picking out their fingernails and their skin for months afterwards. In some cases, it's horrendous. So seeing a Starship land on the lunar surface is going to be interesting, putting it bluntly. But watching this thing take off when you've got the Super Heavy first core stage, and this is going to be for the first time since 1972, since the launch of the first Skylab mission, 72, 73, 74, kind of time with the last of the Apollo missions, which were Skylab, that we've ever seen anything of this scale. I mean, this is going to, for the first time now in 50 years, pretty much surpass what we had with the Saturn V. So hold on to your hats when this thing launches, because it's going to be astonishing. What they're saying is that it's going to be a 6-minute flight for the booster stage, which is then going to drop down into the Gulf of Mexico. And then the main Starship's going to go into orbit. So this is an orbital test, which they're planning in a few weeks from now. So as I said, hold on to your hats. This won't be the full stack, the full configuration that's finally going to be developed, where the main booster stage will have 30 Raptor engines. Now, if you want to know what that will look like, dig back through the archives to the Russian N-1 rocket. So during the great Apollo space era in the 60s, Russia, the Soviet Union as was, were desperately trying to beat the Americans to the moon, and they were developing their own moon rocket called the N-1, which was this behemoth. It was almost the same size as the Saturn V, but a very radical configuration of boosters where you had multiple engines on the first stage that could independently gimbal just a little bit, which is basically adjusting their orientation to kind of stabilize the launch, etc. But then they had this almost like wire mesh interface between the different stages, and that was for thermal dispersion and being able to let the stages separate. This thing blew up every time. Now, it blew up on the pad on one occasion, killing lots of people, blowing up the entire pad and making the pad unusable. The second one, I think, was the largest human-made explosion that was non-nuclear in history, when the N1 blew up on launch. And then the third one, I think, got up to about a few kilometers above the launch pad and then went bang. So that was kind of the end of the N1 program, as it were, but a gigantic rocket. And it's not a similar configuration, but this multi-use of these multiple Raptor engines is very, very similar in its design. So there's going to be 30 on the first stage, 6 on the second stage. I don't know, Terry. I literally jump up and down when this thing lands. When Starship landed, I was genuinely, and I hate Musk for Starlink with a passion. Genius engineer as he and his team may be. What you're saying with Starlink's horrible, but this, I don't know. What's your thoughts, Terry?
I think you're like Marmite. You love and hate at the same time, and I'm the same. Yeah, I think of this as King Kong and Godzilla rolled into one. I mean, this is the big beast. When I think it's 32 Raptor engines altogether in the final configuration. That'll have double the thrust of a Saturn V.
Yeah.
And a Saturn V was just way ahead of anything else apart from the N1. I mean, the Saturn V had £7.5 million of thrust. The Americans always quote in pounds. So this will be double that. I mean, this is an order of magnitude bigger than even NASA has attempted. And this is a private operator doing this. Absolutely amazing. So I gather actually that for the next flight, which will be the main one to go fully into orbit, that the FAA haven't actually approved it yet. And Musk is talking about getting it up before the end of July. So I think we need to sort of watch and wait and see whether that actually happens. But this is really an incredible piece of kit. As it stands at the moment, it's higher than a Falcon with the Starship on top of it. And this is only the first stage. This is basically equivalent in terms of what it does to the first stage of a Saturn V, only twice as powerful.
Yeah, I've seen a comment from Mike, who probably would be able to hear it from Ireland. I've got a friend who was at the launch of Apollo 15, and she was at 4 miles distance, and said it was like somebody had put you inside a washing machine and literally was shaking your stomach with a washing machine. It was that, and that was at 4 miles. There's a really funny YouTube video, if anyone wants to find it after this, with Walter Cronkite, who was the famed journalist, really phenomenal journalist, who used to cover a lot of the Apollo Saturn launches. And he wanted to get a bit closer, so they built him a hut a little bit closer for one of the early Apollo test flights, and literally it collapsed around him. He said the walls were shaking and the whole thing was falling down around him. So watching this thing take off, if you live in the Boca Chica region, I really don't think you know what's going to hit you. And given that one of the Starships blew up at altitude and rained debris down, you say about the FAA, in some respects, Musk has got the United States government over a barrel, because he's developing so much of what they need for their space program in terms of obviously getting astronauts back to the ISS, launching from US soil with the Dragon capsules. Obviously, what he's doing with Starlink is of critical importance. And let's not, again, beat about the bush. The importance of this for the global internet, which is the whole altruistic reason, which is complete baloney. I mean, $499 for a ground station and then $99 a month. Most people, 10% to 20% of this planet, live on $1 a day and can't even afford, clean water. So let's not make any bones about this altruistic, we're giving free internet to everyone. They're not. But they do have the FAA and the FCC, to some regards, over a barrel. And I would very much doubt that they're going to say no. You know, the guy launched in fog. He launched one of the Starships and you couldn't even see it. It was so foggy. So if you want to talk about, you know, launch priorities and launch safety, etc., and range safety, that thing blew up several hundred meters above the ground, rain debris all over South Texas in the fog. So it's going to launch. Whether it launches in July or August, it's going to launch. I mean, their progress so far has been phenomenal. I do want to see it work. I do want to see it happen. I do want to see it take off. I do want to see missions to Mars. I don't want to see them dump 200 prospectors / hippies on the surface of Mars before it's been scientifically explored, because we do need, you know, it's not been explored by humans in its 4.5 billion years of existence. So dumping a bunch of the, as they said in the movie The Andromeda Strain in the late 60s, the most contaminated substance in the universe, i.e. humans, on the surface of Mars is not going to be a good thing. So please, Elon, if any of your team are listening to this, and I very much doubt you are, but if you do, please, please, please talk to the scientific community. I know you're engaging with them about the mega constellations and reducing the brightness, but drop into magnitude 7. Nobody cares. You can't see them. The general public won't care because they can't see them anymore. Every astronomer can hit magnitude 20 to 24 easily with a CCD. So you're not doing anything for astronomy. Again, don't kid yourself. Anyway, let's see. Hopefully, by the time we come on the show next, this thing may even be taking off. So, which brings us to our final main topic. Terry.
Yes. There's the two Bs on the Comet, and now we have Bezos versus Branson in the space race. What can you say? Competition is excellent in terms of developing things. Two very, very wealthy men, and they're going at it. And we were talking a little bit earlier before we come on air as to who's going to win. You are firmly in the camp of Bezos simply because you think Branson isn't actually going to get above the Kármán line, which is the definition of space. But he'll be getting up reasonably high. Yeah. I have a friend who is booked to go up with Branson on Virgin Galactic, so I'm hoping he's successful. But he's hoping to certainly be the first to get up there in terms of the sponsor of the program. They've been given FAA approval to fly passengers into space, paying passengers. Now, since Branson owns Virgin Galactic, I don't think he's actually paying anything. But basically, he is planning to go up on the 11th of July in Unity 22. Which will, 6 people altogether, 8 altogether, 6 passengers and 2 pilots. And as probably most people watching know, what happens is they take off under a big modified aeroplane, basically get the rocket up 4 or 5 miles up, then release the rocket up onto the plane, release it, and then it goes on up to, in his case, about 80 kilometers, 300,000 feet. And as I've just been hinting, that probably is not, according to most people, into space, because that's 100 kilometers. So not above the Kármán line, but pretty close. And I think if he manages that, he'll be more than satisfied. That's high enough to have the sky above you, more or less black. You see the curvature of the Earth. You'll be weightless for a couple of minutes, and then they have a glide back down to Earth at a speed of Mach 3 initially. It'll be quite a spectacular thing. If I had got a free ticket, I would certainly go. But Bezos, I think, will be able to claim that even though he's not planning to launch until the 20th of July, that he'll be the first one in terms of a citizen, apart from an actual trained astronaut or mission specialist, to get up into space. Now, I know other millionaires went up to the ISS, paying a large amount of money to do so, but he has developed this himself, Blue Origin. And for him, in terms of the space billionaires, he's probably the one that can genuinely say that he was the first to get himself up into space. So he actually has done something that I think is very, very worthwhile, as well as himself and his brother Mark and the person that won the charity auction to get the final seat on his flight, who has not been named yet, as far as I know. Yep. He has chosen Wally Funk, who is an 82-year-old woman who should have been in space before. She is one of the 32 female astronauts which were selected slightly unofficially, not part of the original NASA Mercury program, but they called them the Mercury 13.
Yeah.
Women who were qualified and trained and able to go into space, but that program never actually happened. Wally, which is short for Wallace. When I first heard Wally, I thought, well, that must be a guy, but it's Wally, short for Wallace. She's 82 years old now. She was the youngest of those 13 women. So now she's not just too old, but still a lot older than anybody else that will have gone to space. And she also came first in all the tests. She scored the highest marks of all those 13 women. So she missed her chance to go to space before with NASA. By the time they were actually flying women into space, like Sally Ride and so on, she was by then too old to meet their requirements. But now, at 82, she's been given a free ride, and I think that is a magnificent gesture, and I hope she gets up, and I hope she enjoys it.
No, it's fantastic. I've met two of the Mercury 13 at a conference in Arizona, and it was a real highlight, even though they, as you said, they've not been into space and they did all of the same levels of training. Everybody said that, you know, female astronauts were a better pick anyway in terms of physical size and aptitude. They were outperforming all of the men, and it was amazing that it took NASA so long. As you said, Sally Ride, we're talking decades after Valentina Tereshkova had gone up for the Soviet Union, and you could say, well, that was just a PR stunt for the Russians, that they wanted to get the first of this and the first of that. It still took NASA, you know, decades to respond to this, and I love this. I mean, Bezos, you can love or hate him. I mean, Amazon obviously is the richest man on Earth at the moment, or the richest human being on the planet. Is that a good thing or a bad thing? He's investing a lot of money into this space program, and you know, he's obviously had some of the setbacks with lunar exploration, you know, the whole plans for the lunar lander, etc. So again, he's one of these, it's kind of like a dark undercurrent. The thing with Richard Branson is he's very much of a showman. You know, if you remember his stunts in the 80s with you know, crossing the Atlantic and having the fastest speedboat to cross the Atlantic, and his round the world ballooning trips almost cost him his life on several occasions. So he does put his money where his mouth is, and he does take the risk, which, you know, has to be admired. But as I said, and we've said, I love Virgin Galactic's approach. I mean, you know, what they've done, you know, what Scale Composites have done with the spacecraft and the development and Spaceship One. I remember watching Spaceship One, you know, be the first to get the Google X Prize, as it was in the time, you know, the Ansari X Prize. Was amazing. Don't get me wrong. You know, I'd love to see that thing, you know, fly regularly. It's just for the sake of 20 kilometers, you know, stick some more boosters on it, you know, just get it. You know, the first Spaceship One went above the Kármán line. It did it. It went to, I think it was 104, 105 kilometers, and you know, it was there. And this whole notion of 50 mile, 80 kilometers, which is the old US Air Force, and you know, some of the X-15 pilots were given their astronaut wings for flying that high. And you're saying about seeing the curvature of the Earth, you can do that in a U-2 spy plane. You know, you can go up to 30, 35 kilometers, which some of these balloon exploration missions are saying, oh, to the edge of space. Well, it's not. It's 35 kilometers. Space is another 65 kilometers above that. If you want to see the curvature of the Earth, there's ways to do it. You can go up in MiG flights. You can go up in U-2 flights, probably for about half the cost of what this is going to be. What's interesting thing with Branson is what he'll do from a commercial aspect in terms of bringing it, excuse me, more into line with what more people can afford. I'm not saying it's going to be the average person in the street for probably the next 10, 20, 30 years, perhaps. But you look at aircraft and aircraft flight in the early days, it was a kind of rich person's playground. And, you know, it was only the wealthy that went abroad. And then you had the Thomas Cooks, etc., of this world, who introduced really cheap tourist holidays. And they did that obviously with boats in the 1800s through to aircraft in the 1900s, etc. And I think Richard Branson has got a very sharp, keen business mind. Obviously, Bezos has as well, you know, with Amazon. So that's where I think the interest is going to be there. And whether or not Musk decides to react to this, or he just continues with his quest for Mars and his goals and his aspirations along those fronts. But I love, taking Wally Funk up is just the most awesome thing ever. So big hat tip to Jeff Bezos for that, and for taking his brother and whoever the person who spent $28 million on being the first passenger. And people are saying, oh, you know, you've lost 28 million because Branson's going to beat you. He's not. He's going up to 80 kilometers. So Bezos will argue this till the cows come home, that you cross 100, you're in space. There you go. And this is, it's called New Shepard for a reason. It's in honor of, the great Alan Shepard, the only Mercury astronaut to walk on the moon as well. Then we're going to have New Glenn and New Armstrong. Who knows what's going to happen? It's a very exciting few decades ahead, I'd say. So.
Yeah, absolutely. Yeah. It wasn't me that won that lottery. I can say that now.
Brilliant. So we're just going to wrap up now. Thank you so much for everyone who stuck with us. We know there's a big football game on, but it's not the big one tomorrow. We wouldn't have broadcast tomorrow if it was. We're going to go into look up. Terry, what have we got to look forward to?
Very briefly, because we're running a bit late, there have been some beautiful displays of noctilucent clouds recently, and that's up not quite at the Kármán line, but pretty close to it. They are very, very high altitude clouds, using the term loosely. They're basically the dust that forms whenever meteors and small meteorites burn up in the upper atmosphere. At this time of year, you can see them in the northern part of the sky, just about local midnight, and they're called noctilucent, which means night shining, because they are so high up that the sun illuminates them, even though it's far too far below the horizon for the sun to illuminate ordinary, what we call tropospheric clouds. You see them low down, just above the northern horizon, silvery, bluish white, sort of tenderly like clouds shimmering. If you take a video of them, you can see the way they move. They're quite beautiful. They're distinctly different to any other clouds that you'll see. And in fact, if you have some foreground clouds in the sky as well, they'll appear dark against these bright clouds. So we get about another 2 weeks or so before the season ends to see them. If you're up early in the morning, you get a chance to see Mercury, the innermost planet, low down in the northeast morning twilight, and you have two really good chances, although it'll not be at its brightest, tomorrow morning. Just in sort of the dawn twilight, it'll be below and to the left of the waning crescent moon, about half the length of the plough away from it, if you know that. And then the next night, not tomorrow morning, but the morning after that, the moon, with slightly smaller in apparent size, will be just above it. But you'll actually be able to see Mercury low down in the morning sky and the morning twilight, right up to the middle of July. And if you're in the southern part of the country, you see it far better. If you're up in northern Scotland, it'll not be so easy. And also, if you're up at that time of the morning, look out for passes of the International Space Station, which we have mentioned. It's doing a series of morning passes at the moment. In other words, again, just before the sky gets too bright in the morning. Those will continue until about the middle of July. And then, for reasons which are a bit complicated and not explained, they transition directly into a series of evening passes. So we'll be able to see the ISS in the night sky, if it's clear, right up to the end of July. Saturn and Jupiter, we again mentioned them with the comet coming into the orbit of Saturn. They're also visible in the early hours. Saturn appears up above the horizon first, and then Jupiter about 20 degrees behind it. And they're well worth looking at in any small telescope, particularly Saturn with its beautiful rings. But we'll probably say more about them later whenever they're at an even better position for observing. So that's what to look out for.
Absolutely. And, I saw some noctilucent clouds a few weeks back when we had a brief gap in the persistent rain that we seem to be having here in the UK. Hopefully, friends listening around the world, anyone who's listening in Canada or North America, etc., definitely keep an eye out for the noctilucent clouds, because this year it's been the one night I got to see it, absolutely spectacular. Saturn is one of those things that the first time you see it, you never forget it. And from a STEM perspective, being able to show kids, in particular Saturn through a telescope, it really is a wow moment. Jupiter as well is truly beautiful. Mercury, you just got to be really careful, obviously, because you are looking at an object which is sunwards from us, and you've got to make sure that the sun is nowhere near where you're looking, and don't go swooping around with binoculars, etc., because even a split second looking at the sun through binoculars, even when it's low in the sky, can cause permanent blindness. So please be careful. And then the ISS, it's just one of those things. You're looking at it going overhead and you're thinking, this thing's traveling, it's moving across, it looks like a high altitude aircraft, it's not blinking. But you think this is traveling at 17,500 miles an hour. And sometimes there's astronauts outside it fixing it.
Yeah.
And you just think that's just incredible. And you see some people with telescopes who look at it and follow it and track it with the telescopes and take incredible images, even of the astronauts. You can see the astronauts from the ground if you've got a decent sized telescope. Again, just absolutely amazing. And another fun thing, if anyone's feeling a bit nerdy, something like a little Raspberry Pi, these little pocket computers, or even your home computer, you can get a thing called a software-defined radio, an SDR. It's like a little USB key, it looks like. They cost a 10, 15 pounds on Amazon. You can plug those in, connect it up to an aerial in your garden, and you can listen in to the ISS, and you can listen into satellites as well. So even if it's cloudy, you can still either download images from it, because they use a thing called slow scan TV, SSTV, on the space station sometimes to send down images, or you can get images from weather satellites. Just Google it, SDR radio and satellites. It's a phenomenally fun little project to do, especially as we're just coming out of lockdown now, and semi-normality is coming back to the planet for some of us anyway. Obviously, international travel still pretty much prohibited anywhere, but it's just a great fun thing. And one of the key things we've always tried to do here with the guys at Space Store is really advocate and promote the STEM aspects of what we do. Try and do something that's fun, and try and engage the next generation of scientists and astronomers, etc. Most astronomy clubs are full of people like Terry and myself, like old white guys, as it were. Science is for everybody. Science and space is for everybody. Doesn't matter who you are, where you are, anywhere in the world, gender, whatever, it doesn't matter. It's so important that we engage so many people to understand the beauty of science, because science is what's got us through the pandemic. Science is what's giving us this freedom again. So that's all I can say. Just love science, as it were.
Yeah. The beauty about the ISS and some of the other things, again, like Jupiter and Saturn, you can see them without any optical aid whatsoever. The ISS at its best is almost as bright as Venus, which is the brightest object in the night sky apart from the moon. If you don't know just when to look, there are quite a few websites. The one I think is easiest for most people to use is Heavens Above. But there are other ones as well. If you just use a search engine, you'll find various ways which will tell you just where and when you can see the ISS from your own particular location. So it's something that's amazing, as you say, traveling at 17,500 miles an hour. It goes across the sky from horizon to horizon in 6 minutes, roughly, in terms of when it's visible. Absolutely phenomenal. So if you've never seen it, do make an effort to go and see it.
Yeah, and you can get apps for your phone. If you've got an iPhone or Android phone, you can get apps like ISS Predictor, etc. They'll literally set off an alarm when it's going overhead. So you don't even know. You can say, give me a 5-minute warning, and then you just nip outside, take the kids outside and go, look at that. Isn't that amazing? And trust me, they will. And especially at Christmas time, near Christmas, if you've got very young kids, you can say, look, there's Santa. So it's brilliant. And on that note, thank you again for sticking with us. A massive thank you again to the Space Store. My dear friend Terry, who we still need to meet up very soon. Hopefully once the travel restrictions are lifted and my nation and your nation are kind of able to see each other, that's going to be incredible. Visit the Space Store. They're coming out of lockdown as well. They've got some great stuff. They do some fantastic kids experiences. They've got some wonderful gifts if you're looking for something unusual to give to your kids or your loved ones, for example. Definitely check them out. They're based in Didcot, right near the Harwell Space Centre, Space Cluster, which is doing incredible work with their new satellite test facility. And Harwell was one of the key scientific institutes that was working really hard on COVID for the last 18 months. So a lot of the work there, they've been doing hasn't been to do with space. It's more been to do with saving lives. So it's a great day out. It's a great place to visit. Check out the Space Store, and I'll hand you back to our amazing host, Latch.
Great. Thank you so much once again for an amazing show, Nick and Terry. It's always a pleasure having you. Thank you also to everyone who's joined us this evening. We've had a wonderful crowd in tonight, choosing us over the football. So thanks again. You can also head over to spacetour.co/events to check out the upcoming space events that we've been talking about tonight. It's been an incredible show. Remember, we'll be back here on Thursday evening at 7 p.m. with another Space Tour live talk. And this time it's with someone special from Astro Agency, one of our latest Space Tour partners. So we'll see you back here on Thursday evening. Take care. and we'll see you guys on Thursday.
And we'll see you in 2
Okay.
weeks for our next show.
Yep. Bye,
Yeah,
everybody.
in a couple of weeks'
Thanks
Bye,
for
everyone.
watching.
All right. See you
Thank
later,
you.
everyone.
Bye.
Good evening.
Hi, my name's Nick Howes, space enthusiast, author, writer, broadcaster.
Hi, I'm Terry Moseley, past president of the Irish Astronomical Association, lifelong astronomy and space nerd, absolutely fascinated by everything, both man-made and natural up there.
So every 2 weeks, Terry and I give you the latest, hottest news from space and human spaceflight, robotic spaceflight, and what's happening up in the skies. Please tune in to us every fortnight with the Space Stuff. Adios, amigos.